I'm going to explain to you bounds, okay, upper bound, lower bounds, worst case scenarios. Here we've got area is equal to length times width. So just to pretend I measured a piece of cardboard, its area, to get the area, and I can't remember what the length is. It's either 5 centimeters, 10 centimeters, 15 centimeters. Can't quite remember, and I haven't got that cardboard with me. And the width, I can't remember whether it's 2 centimeters or 3 centimeters. So I want to know the worst case scenarios, right? What could be the lowest possible, or lower bound at the lowest possible area. Now here's the formula for the area. Here it is. It's length times width. So to find the lowest possible value for area A, I'm going to pick the smallest value for the length, smallest value for the width. Smallest value for the length is 5 centimeters and the smallest value for the width is 2 centimeters. That's 10 centimeters squared. Right, the highest possible value for the area, I've got to pick the biggest value for the length and the biggest value for the width. That gives me 45 centimeters squared. Right, so that's the upper bound for the area, lower bound for the area, worst case scenario. Now for this one, I've got distance divided by time is equal to speed. Let's suppose the distance could be any one of these numbers, 100, 200 or 1000, can't remember, right? But I know it's one of those three values. And for the time, it's one of those three values there. So to find the lowest possible speed, worst case scenario, one of the worst case scenarios, the lower bound, I'm going to do distance divided by time. So I'm going to pick, remember I'm trying for the lowest speed, right? So I'm going to put the lowest number in the numerator and the highest number in the denominator. That combination, when you do divide, will give the lowest possible answer. So let's go for that then. Lowest number for the distance and the highest value for the time. 100 divided by 10 is 10. The units are meters per hour. All right, it must be a snail. The highest, so the other worst case scenario, the highest possible value could be, to get that, we need the biggest number of the numerator, smallest number on the denominator. 1000 divided by 1 is 1000 meters per hour. All right, it might not be a snail after all. All right, so you've got to understand these, right? Here, remember for the area, we were timesing length times width. So to find the lowest possible value, we had to put the smallest values for both length and width. And for the highest, we had to put the highest values into length and width to get the area. Because remember, we're timesing here, not dividing. Whereas with this one, distance divided by time, to get the smallest possible value for speed, you have to put the smallest value for distance and the highest value for time. But going through this question, I'm not going to teach you how to do SOHCAHTOA, how to apply trigonometry to this question, or how to find upper bound, lower bound of numbers. But what I will do is show you how to go about finding the upper bound of length BC, this over here. Right? If you want to know how to use trigonometry and how to find upper bound, lower bound, you're going to have to watch my previous videos on this. Right, first of all, 7.2 has been ranged to 1 dp. AB is equal to 7.2. It's been ranged to 1 dp. So the upper bound, put a 0 there, it'll help you. The upper bound is 7.25 and the lower bound is 7.15. Right, for this 40 degrees, it's been ranged to 1 SF. So angle ABC is 40 degrees. It's been rounded to 1 SF. The upper bound for that is 45 and the lower bound is 35. So if you used to pick any number which is less than 45 but bigger than or equal to 35, rounded to 1 SF will give you the 40. Since this is trigonometry, I'm going to use SOHCAHTOA. I need to label the sides. Obviously this is the longest side, this is hypotenuse, this is opposite, this is the side that's opposite the angle that we're going to use in the calculation, and there's only one word left, adjacent. One of those words is irrelevant, it's opposite. It's relevant because I'm not after this side and there's no number there that I'm going to use in the calculation. So I need to find the triangle that's got the word adjacent and hypotenuse. It's this one here. So let me just develop that a little bit bigger. So I've got adjacent, I've got hypotenuse, and I'm going to have cos some angle. Right, I'm not going to put 40 there. Alright then, I need to put some numbers now. I need to substitute the numbers. Remember, I'm trying to find the upper bound of length BC. So the calculation that I'm going to do to find adjacent is cos x multiplied by hypotenuse. To find the upper bound, I need to put the biggest value for cos x and biggest value for hypotenuse. Now, hypotenuse, I'm going to use 7.25. That's the biggest value. But for the cos x, I need to be very careful with this. So what I'm going to do, I'm just going to do a little experiment here. I'm going to use cos 35, see what I get. Cos 35, I can use a calculator for this. Cos 35, 0.819, and I'm going to try cos 45 now. I get 0.707. So actually cos 45, the bigger angle, the cos of the bigger angle gives me a smaller value, all right? But I'm trying to find the upper bound. Remember, I'm going for the upper bound, so I'll need the largest possible value for cos x, and I'm already using the largest possible value for the hypotenuse. So what I'm going to do now is use cos 35 instead. Cos 35. Cos 35, that gives you the largest value, all right, as opposed to cos 45. So if I do that now, if I work out the calculation, cos 35 multiplied by 7.25, I get 5.9 centimeters. Right, that's the upper bound based on the calculations that I've used. Right, here's a mistake some people do. They don't bother finding the bounds, upper bound or lower bounds, for the numbers in the question. They just go straight for the calculation. They just end up putting, for example, they'll put 7.2 there, and then they'll do cos 40. Right? They'll do that, and they'll get cos 40 multiplied by 7.2. They'll get something like 5.5, and then they'll say, oh, the upper bound is 5.55. Right? That we don't do. What you need to do is find the bounds right from the beginning, like I did here, here, and then use the appropriate calculations using those bounds.